In this video, we're going to talk about forces and friction. Now we'll see the definition, we'll see the types, examples, laws, advantages and disadvantages, how to control friction, and then we'll see the calculations. Now, force is anything that causes motion, as simple as that. It is a vector quantity and its SI unit is Newton, capital letter N. That's Newton, named after Isaac Newton. Now it is divided into three categories. The categories for forces. The first one that we have is field force or forces. Now these are forces that do not require contact with another body to be exerted. Example is magnetic force, gravitational force, electric force. These are the examples of field forces. They don't require contact with another body before they are exerted. Now, the next one is contact force or forces. Now, these ones, even from the name contact, you already know what it means. They are forces that require contact with another body before they are exerted. Now, or in order to be exerted. Now, example is you have pull, you have push, you have friction, you have buoyancy, drag, that is air resistance. Example, feather, air resistance to feather. Now, the third one is called reaction forces. Now, these ones are those forces that act in opposite direction of the line of action. Example is tension, upthrust. Now, one thing you need to know is that generally, force F is given as mass times acceleration. So, we're going to be using M for mass. So, F, force, is equal to mass times acceleration, which is ma. Now, force in a system of forces. So, we'll say in a system where you have more than one force. In a system of forces, we have that summation of the force is what is equal to mass times acceleration. Now, this force, what we mean by is the force that you apply. The force that you apply minus the opposing force. That is what gives you ma. That is force. Force apply, opposing force. That is what gives you force. Now, what I mean by that is if I have something, this is a surface. This is a surface. I am applying this force in this direction. Now, there are also opposing forces that make sure it doesn't move. It is this force applied minus opposing force that is what gives me ma. For this load, for this mass to move in this direction, it must overcome this opposing force for it to move in this direction. So now we look at friction. Friction simply is a force which tends to oppose relative sliding motion between two surfaces in contact with each other. We have some types. We have a solid friction, that's under types. We have solid friction. This is a kind of friction that occurs between two solid surfaces. Okay, two solid surfaces. Now, we also have fluid friction. This acts in air or liquid. So, these are the two. we now have types of solid friction. Under this, we have types of solid friction. We have static friction. This static friction is the one that acts between two solid surfaces at rest. The word static means rest. Solid surfaces at rest. And we also have dynamic friction. This is a friction that acts between surfaces that are in motion. Dynamic. So now let's look at the laws of friction. We look at the laws. We have that number one, friction depends on the nature of the surfaces in contact. How rough, how smooth, that is what it depends on the nature of the surface, the surfaces that are in contact. Number two, okay, let me write them down. So the laws is that friction depends on the nature of the surfaces in contact. The second one is that friction does not depend on the area of surfaces in contact. It doesn't matter how small or how large the area is. No, friction does not depend on that. The third one is that friction depends on the normal reaction to the plane and not on the weight of the body. You need to understand that. And the fourth law is that friction varies directly as the normal reaction acting on the body. If we write it mathematically, we said friction varies directly as the normal reaction. So if we remove the proportionality sign, we can bring in equality sign and introduce a constant, so that when we introduce the constant, we need to know that this is called coefficient of static friction, is a constant. Now, you also need to note that reaction depends on the angle between object and the plane and the horizontal surface. The reaction depends on the angle between object of the plane and the horizontal surface. That's what we mean by that, is that reaction is equal to mg cos theta. Now, if we have that the plane is horizontal, if plane is horizontal, then this is the weight W. So R is equal to mg cos theta. R acts in this way. That's the normal reaction. So, but if plane is inclined, number two, if plane is inclined, so we have, if plane is inclined, this is the weight. Now this is the angle theta. The angle goes the normal goes like this. The normal reaction is this way. Then R is equal to mg cos theta. The third scenario is if the plane is perpendicular. If it is perpendicular, we have something this way. Then if this is the load, we have that the weight of this goes like this and the normal is like this. So R is equal to mg cos theta. Now, for horizontally applied force, that is the scenario we had initially, applied force. Now here is opposing force. Let's add another one and make this one frictional force. So this is the surface. We said that F A, which is applied force, minus the opposing force. The opposing force is now opposing force plus frictional force. Remember, the two of them, they are now acting as opposing force. Is now equal to MA. For inclined plane, For inclined applied force, we have something in this way, or let me make it where it will be easier. If this is the inclined applied force, that's the second scenario. Inclined applied force, that's the inclined, this is the normal, this is the inclined applied force, means applied force. Now the normal reaction R is equal to mg. So this is the mass. Remember, the opposing forces goes this way. Here in this case, you need to remember that Fa cos theta minus Fo minus Fr is what gives us Ma. We're going to use this in the calculations. Please note them. Now let's talk about the advantages. The first advantage is that friction makes motion possible. So it makes motion possible. So the reason your car moves is because of friction. The reason you walk is because of friction. When you walk on a very smooth surface, you notice that if you don't take care, if you don't take your care, then you're going to slide or fall. So it makes motion possible. That's why athletes, under their shoes, they have grips so they can run faster. Number two is that it aids in sharpening of tools. If you check the equipments used in sharpening of tools, you notice that their surfaces are very rough. Yes, that is to aid friction, to help in sharpening of tools. When you want to sharpen your knife, you go to a rough edge of a pavement, and that's where you sharpen it. That's friction. Number three is that it aids in grinding. Now, let's look at the disadvantages. So the disadvantage, one of the disadvantages is that number one, it wastes energy. Number two, causes heat. Number three, causes wear and tear. When you check your knife that you have been sharpening over time, you notice that how big it used to be is no longer how it is now. It has been wearing, it has been reducing. So now, how to control friction? You can control friction. Number one is by use of rollers. If you've seen men carrying heavy things, you notice they put rollers under them. If you see men sit in office, they put rollers under them so that their chairs can move while they are seated on it. Because friction ordinarily will not allow the chair to move, so they put rollers under it so they can easily slide. They are reducing friction. And number two is use of lubricant. Lube. So use of lubricant. Okay, let me write it in full. Lubricant. When you apply grease, you notice that it helps. It controls the motion. It helps to control the friction. Okay, so let's another one also. I remember number three. This is number two. This is number one. Number three is also introducing gas layers. You can introduce gas layers between surfaces. So introduction of gas layers. So when you introduce gas layers in between surfaces, you've reduced motion. One more thing you need to note here is that whenever the surface is smooth, it means that the coefficient of static friction mu is equal to 0. Always note that. Please do not forget to subscribe to this video. Thank you.